Welcome to this explainer. Right now, we're literally watching a massive structural earthquake shake the entire software industry. We're talking about a profound shift from writing syntax line by line to expressing intent and letting AI do the heavy lifting. I am so excited to guide you through this because it's going to change absolutely everything about how we build software. Okay, let's dive into this with a quote that absolutely took the developer world by storm in early 2025. Andre Karpathy hit the nail on the head when he said, "Fully give in to the vibes, embrace experientials, and forget that the code even exists." That perfectly captures a phenomenon we now call vibe coding. It's this wild, fast-paced way of just talking to an AI and letting it spit out software. Now, you might be thinking this is just some trendy, futuristic concept. Well, look at this staggering number. As of early 2026, an estimated 41% of all new code is already AI generated. This is a massive narrative jolt. We aren't just waiting around for the AI coding revolution, we are living right in the middle of it. And the stakes for how we manage all this new code are incredibly high. So here is our cognitive roadmap for today. We'll start with the end of syntax, compare vibe coding with agentic engineering, explore the new AI SDLC, unpack how to harness the AI engine, break down the economics of AI, and finally, look at intent as our new interface. Let's get into it. Number 1, the end of syntax. We're moving from how to build to what to build. For decades, our interface with machines was, well, incredibly strict, right? Curly braces, semicolons, type annotations, perfect grammar. If you missed a single character, the whole shebang breaks. But that era, it's rapidly coming to a close. Just look at how fast this progression happened. We started with simple autocomplete around 2021. By 2022, we had inline suggestions completing entire functions for us. In 2023, chat-based generation meant you could just describe a feature and get working code. And now, we have fully autonomous coding agents. Today, 85% of professional developers use these capabilities regularly. This isn't a linear progression we're looking at, it's a massive exponential curve. So the crucial point here is understanding what an agent actually is. A lot of people confuse this. Unlike a standard chatbot that just spits out a single response and waits patiently for your next prompt, an AI agent runs its own continuous loop. It perceives a goal, plans the steps to reach it, takes actions using tools, observes the results of those actions, and iterates entirely autonomously. This loop is the absolute beating heart of every single agent. Perceive, plan, act, observe, iterate. What makes this such a game changer is that if a step fails, say a test doesn't pass or a file is missing, the agent doesn't just stop and give up. It observes the failure, self-corrects, and tries a new path without you having to type a thing. Moving on to section 2, vibe coding versus agentic engineering, which really defines the AI spectrum. Let's look at the two extremes on this spectrum. Vibe coding relies on casual, natural language prompts, manual checks where a developer just squints and says, "Yeah, it looks right," and it's mostly for disposable prototype code. Agentic engineering, however, demands formal specs, automated evaluations, and it operates at real production scale. Verification is the dividing line here. Honestly, telling your CTO you are vibe coding a new payment processing system should absolutely set off alarm bells. Now, what's really interesting about this slide is how context engineering solves the gap between those two extremes. To make an agent actually reliable, you have to balance static context, which is always loaded, token-heavy, but contains your unbreakable foundational rules, with dynamic context, which is loaded on demand, highly efficient, and holds task-specific skills. Balancing these prevents token bloat while keeping your agents laser-focused. Section 3, the new AI SDLC. We are completely transforming the development lifecycle. The traditional software development lifecycle, the SDLC, is literally warping and compressing under the sheer speed of AI implementation. Let's walk through exactly how these phases shift. Requirements gathering. Well, that's now simultaneous prototyping. Architecture, that actually remains deeply human-centric because of the complex business trade-offs involved. Implementation plummets from taking weeks down to mere hours. But here is the catch. Testing now has to verify not just the output, but the trajectory of how the AI even got there. In fact, a recent industry study by Matriacron found that developers sometimes take 19% longer just verifying and debugging AI output. You type way less, but you review much, much more. This brings us to a really powerful analogy, the factory model. In this new paradigm, your primary output as a developer isn't really the code itself anymore. Your output is the system of specifications, agents, test suites, and guardrails that produces the code. You are no longer the assembly line worker tightening bolts. You are the factory manager ensuring the assembly line produces high-quality widgets day in and day out. Let's move to Section 4, harnessing the AI engine and building the system around the model. Let's step onto that factory floor and move past the most common mistake builders make, which is obsessing solely over the AI model itself. This is a brilliantly simple equation that you should definitely keep in mind. Agent equals model plus harness. When an agent messes up, our first instinct is usually to blame the model and wait for a newer version. But the truth? Most agent failures are actually configuration failures in the harness, not limitations of the model. And this brilliantly illustrates that reality. The model is only about 10% of the equation. It's just the raw engine sitting on the factory floor. The harness makes up the other 90%. Think of the harness as the chassis of the car, the paved road, the safety sensors, and the traffic laws all rolled into one. So what exactly is inside that harness? Well, it's your instructions, like an agent's MD file. It's your tools, sandboxes for secure execution, orchestration for routing tasks, guardrails to prevent absolute disasters, and observability to trace what happened. To prove how vital this is, one team tweaked just their harness without changing the underlying model at all, and it launched them from outside the top 30 all the way to the top 5 on the Terminal Bench 2.0 coding benchmark. Just the harness. All right, Section 5, the economics of AI. Let's talk CapEx versus OpEx in this new token economy. Let's pull back for a second and look at the financial realities that engineering leaders care about most. Because AI coding is definitely not free. Vibe coding feels incredibly cheap up front, meaning low capital expenditure or CapEx. But it creates this massive prompting tax and technical debt. This results in very high operating expenses, or OpEx, down the line. Agentic engineering, conversely, requires a high upfront CapEx investment to build your harness and test suites. But the OpEx drops dramatically because of efficient token routing and scale. It's really the only economically sustainable path. Let's move to our final point, Section 6, and see how this all builds to intent as the interface and the evolving role of the developer. This all builds to how human engineers must adapt their daily workflows. The developer's role is basically splitting into two distinct modes. First, the conductor, who works in real time right inside the IDE, maintaining keystroke-level control for exploratory coding. Second, the orchestrator, who delegates high-level goals asynchronously and reviews multi-agent outputs. The absolute best developers aren't just one or the other. They fluidly shift between conducting for exploration and orchestrating for massive production scale. But as you embrace this new way of working, you will inevitably hit the 80% problem. AI will rapidly generate 80% of your code, which is great. But that final 20% of edge cases, that demands deep human contextual knowledge. AI errors are no longer just simple syntax mistakes that break a build immediately. Nope. They are subtle, insidious architectural failures that look perfectly correct at a passing glance. So I want to give you a concrete action plan to take back to your teams. 1. Set up an agent's MD file immediately to define your rules. 2. Write your tests and evaluations before generating any code. That is your contract with the AI. 3. Route deterministic, simple tasks to smaller models to save money. And 4. Treat context as code. Stop waiting on hands to type out boilerplate and start using human minds to carefully define boundaries. Which brings us to the final thought I want to leave you with. Think about this. Generation is solved. The AI can write the code. But are you ready for verification? It's a question every single engineering team needs to answer right now if they want to survive the future of software development. Thanks for joining me on this explainer, and keep learning.